Hey, trig students, section 9.8. It is the last section of your first chapter of trig in your algebra trig class. So this section is called reference angles. I'm going to go through and sort of write some kind of, you call them equations, I guess, but in the end, I think drawing a picture is as good a way as any to get this understanding, and I'm going to do a little thing with our calc too to understand. So really what the bottom line is that every single angle on the unit circle has a reference angle in quadrant 1, the happy quadrant, where everything is positive. And so reference angles are really just about figuring out, whether you're in quadrants 2, 3, or 4, what the corresponding reference angle is that's in quadrant 1. And it's really about geometry, I guess I would say. So I'm going to start with quadrant 2, and it also has to do with like understanding how your calculator operates, because reference angles are going to help you. So if you are in quadrant 2 in some angle, quadrant 2 at some angle, the question is, how would you figure out what angle corresponds to that angle? And really what we're saying is this angle has a certain amount of number of degrees that it's above the x-axis, if you want to think of it like that. So there's an angle over here that has that same number of degrees above the x-axis that's going to have the exact same coordinates, except the signs, S-I-G-N-S signs, are going to be different. And so if you just want to figure out then what the reference angle is, how you get yourself back to the happy quadrant 1, if you think about it, really all you have to do is take your angle, your theta angle, call it, that gets you into quadrant 2, and if you take 180 and subtract theta, you get this little sliver of an angle here, which is the same angle over there. So the reference angle then is 180 minus theta. I'm going to just erase this because I don't want to make it too confusing. So say the angle theta is 150, for instance. So this is 150 degrees. Then I think your geo brain would understand that this is 30, so it should make some sense to you that if I go over here that this is also 30. So the reference angle, 180 minus 150, would be 130. So now, how do we relate to the reference angle? Well, the sine of the angle in quadrant 2 is going to be exactly the same as the sine of your reference angle, because we're in the land of positive y values. The cosine of your angle in quadrant 2 is going to be the opposite of the cosine of your reference angle, because in quadrant 1 the x value is positive, and in quadrant 2 the x value is negative. The tan of your angle in quadrant 2 is going to be the opposite of the tan of the reference angle in quadrant 1. So to play with that for a second, let's just use 150, okay? And so you'll notice, take the sine of 150. I'm going to just do it right on my calculator. We could talk about exact values, but today I don't want to focus on that so much. So I'm going to hit the sine of 150, and I'm going to hit enter. And so based on what I just wrote, it should be true then that the sine of 30 should be exactly the same. And that's, you see that there. So now, if I take my cosine of 150, and this crazy decimal should start to become kind of familiar to you, should be equal to the opposite of the cosine of 30. So I'm just going to go ahead and type the cosine of 30 in, and you'll see here that the sine is positive in quadrant 1 and negative in quadrant 2. And then the same thing would be true for my tangent. So if I take, I'll hit clear here, if I take my tan of 150, I get a negative value in quadrant 2, and if I take my tan of 30, I will get the exact same value, but it's going to be positive in quadrant 1. So like that, I'm going to do this for every one of these quadrants, but really that's what the bottom line is, okay? So we saw that I'm going to focus on sine here for a second. So the sine of 150 is 0.5, and the sine of 30 was also 0.5. Okay, so here's where the issue comes on your calc. If instead you're told that you have an angle whose sine is a half, and you can't figure it out on your own, you're going to use your calculator, if you recall, what we do is we use sine inverse. So if I take the sine inverse of 1/2, so I'm saying, hey calculator, tell me the angle whose sine is 1/2. So I'm going to go there right now, and I'm going to hit, I'll clear this, I'm going to hit second sine, and I'm going to type in 0.5. You'll notice that my calculator is telling me it's 30 degrees. But we know, because we just did it, that there's also another angle in quadrant 2 that has a sine of 1/2, which is 150. So this is where you need to start understanding your calc. Your calculator's favorite quadrant is always going to be quadrant 1. So if there's something in quadrant 1 that it's going to be able to respond to, it's going to do that when you're using your inverse functions. So this is just one of those things you need to be careful. We'll play with this a little bit more, but if in this case, say someone said, hey, find an angle in quadrant 2 whose sine is 1/2, the way that you would use this is you'd say, okay, calculator, you're telling me there's this reference angle 30 degrees in quadrant 1. Well, I know that sine is also positive in quadrant 2, so I'm just going to ship on over here. I know that it's got to be in the same position, and so then I can either use 180 minus 30 or just sort of use the geometry of it to realize that this angle here of 150 is also going to produce that 1/2 as a sine value. And I could check that on my calculator. Practice will help you with this. Okay, so now let's take a look here at quadrant 3. So quadrant 3, and I've written a little too big here, so I'll make a little boundary. So what goes on in quadrant 3 with reference to quadrant 1? Well, if you notice, if I were to extend this segment out here, hopefully you would agree, vertical angles, good old geometry, that this angle and this angle have to be precisely the same. So there is a relationship between this point and this point because they are the exact same amount above or below the x-axis and the same amount to the right or to the left of the y-axis. So in quadrant 3 then, my reference angle, to get me back into quadrant 1, is going to be whatever my angle is, really. So call this theta, that gets me there. And then if I just subtract 180, so I'm going to subtract this 180, I have found this angle right here, which is this angle right here. So my reference angle for quadrant 3 to get myself back into quadrant 1 is going to be whatever the angle is, subtract 180. And I'm just going to run through the same thing again, and I'm going to just think to myself, well, what goes on between quadrant 3 and quadrant 1? So if I think about sine, I'll start there. So the sine of an angle in quadrant 3 is going to be the opposite of the sine of its reference angle in quadrant 1, because sine has to do with y values. The cosine of an angle in quadrant 3 is going to be the opposite of the cosine of its reference angle in quadrant 1, because it has to do with the x's. The tan of an angle in quadrant 3 is going to be the exact same value of the tan of the angle in quadrant 1. If you go back to all students talk constantly, we know that everything is positive in quadrant 1 and tangent's positive in quadrant 3, so that should make sense that these guys are going to be the same. Now I could go through a similar process playing with angles here to show you this, but I would propose that you maybe give that a go on your own. If you want, you can stop the video. So say, you know, play around. Say this is 210 degrees. See if you can figure out what is the reference angle over here and see this relationship. Okie doke. Last, quadrant 4. So, if you notice what goes on in quadrant 4, well, we're taking a big old wrap to get over here to quadrant 4. So geometrically, hopefully you can see that there's something in common with an angle that's, I'm going to think of it as a certain amount below the x-axis, is going to have a lot in common with the angle the same amount above the x-axis. So this point here and that point here are going to have the actual same values, except their SI, G, and S signs are going to have some things that are different. So if you want to figure out a reference angle to get you from quadrant 4 back to quadrant 1, you're just going to take 360 and subtract your angle. So hopefully that should make some sense. If I go the whole way around, that's 360, and if I subtract out what the actual angle is, this, I'm left with this slice of pizza right here. Now, things about reference angles you can memorize if you're a memorizer, but I really feel personally that for the long term, if you can just sort of relate to what's going on by drawing a picture, that's your best bet. So now let's think about this. If I have a sine of an angle in quadrant 4, how does that compare to its reference angle, home base, in quadrant 1? It's going to be the opposite of its reference angle, because sine has to do with y, and the y's are different. The cosine of an angle in quadrant 4 is going to be exactly the same as the cosine of its reference angle, because the x values are positive in quadrant 1 and 4. And the tangent of the angle in quadrant 4 is going to be the opposite of the tangent of the angle in quadrant 1 that it corresponds to, its reference angle. And the thing to think about with tangent, maybe you've already been thinking about this, but basically tangent's kind of kitty corner. So like tangent's positive in quadrants 1 and 3, and tangent's negative in quadrants 1 and 4. It's kind of the way I think about tangent. And I would propose, why don't you try an angle? Play around with it a little. Maybe 330 degree angle you could try. Stop the video and see if you can see this relationship. Okay, so I'm going to run through a couple examples that sort of use this concept of reference angle. So express the cosine of 260 as a function of a positive acute angle. The only way you're going to be able to do this is to know what a positive acute angle is. Acute would be less than 90. Okay, so positive is basically get yourself into quadrant 1. So if we want to think about the cosine of 260, and I'm going to do this by drawing a picture. The cosine of 260. And the more familiar you are with the unit circle, the more success you're going to have here. So this gets me to 90, this gets me to 180. I know if I keep going down to that y-axis, I'm getting to 270, so I am going to stop right here. So, really what I need to do then is say to myself, what angle corresponds to this angle of 260 back here in good old happy quadrant 1? And so I have a 260 here at this point, and I've passed 180. So if I just take 260 minus 180, I know, and you can see this up in the reference angles, I know that 260 minus 180 is 80. Therefore, if I come back up here, this is 80. So it is a fact then that the cosine of 260 has to have the same value as the cosine of 80. But because I'm in quadrant 3 where my x's are negative and quadrant 1 is where my x's are positive, I need to put a negative sign in front of it. So let me just prove this one to you on your calculator. So, and this is always the best way to do this. You want to check to make sure that whatever you did makes sense. So cos of 260, I'm going to hit enter, and now I have decided that negative cosine of 80 should have the exact same value. Okay? And sure enough it does. So it is important that I put this negative sign in front of that cos of 80 though, because of this fact that these values are going to be opposite signs. Okay, another one. Express tan 545 is a function of a positive acute angle. So basically we're doing the same thing, get ourselves into quadrant 1. So the problem with the tan of 545 is it has taken a more than one wrap around the unit circle. So how can we get this to find something we can relate to? We can take a wrap off of it. So it is a fact, if I just subtract 360 from that, I'm going to have an angle that's going to have the exact same value. So 545 minus 360 is 185. I'm going to do the exact same process again. So I'm going to say to myself, okay, tan of 185, and I'm going to just start drawing my angle. 90, 180, oh, 185 is right here. So this is just a little bit beyond that x-axis over there. So what do I need to do? This really is all about getting back to the happy quadrant. So I'm going to shoot this guy back here. And I can be memorizing those equations I just showed you, but if I just realize this is 5 degrees below, so that has to be 5 degrees above. And these points are going to have something in common, and we just have to think about the signs, positive or negative. So, as I said, kitty corner are going to have the same signs. Tan is positive here, so the tangent of 5 should give me the exact same value as going all the way back to the tan of 545. And I'll let you check that one on your calc. Okay, a couple more problems just to think about this. Express the tan of negative 250 as a function of a positive acute angle. So once again we get trouble, negative 250. So going back to what we learned, if I put a wrap If I add a 360 to it, I'll come right back around to the exact same terminal side. So really what I'm looking at, something I can relate to, is the tan of 110. And I'm going to do the same thing. It's worked for me for many years. So I'm going to go to 90. I know if I keep going to my x-axis, I'm going to get to 180. I don't want to go that far, so I'm going to stop here at approximately what I think is 110. Okay, so this is 110, so I'm going to think the same thing. Really what I need to do is find the angle back here that's in the same position. So if I just figure out what this angle is, 180 minus 110, which is equal to 70, that is the angle I want to get back at in my quadrant 1. So now all I got to do is think to myself, well, what goes on with tangent in quadrant 2 versus tangent in quadrant 1? And they are opposite. So I'm going to write the negative tan of 70. And once again, you can check that on your calc. Okay, a couple more. And at any point, stop. Let you give it a go, and then come back and see if we agree. The sine of 420, we get the same concern here. We're beyond 360, so I'm going to take 360 away from that 420. So I'm really looking for the sine of 420 minus 360, which is 60. Now, this one has a twist because it says exact, okay? So, find the exact function value of the sine of 420. So, the sine of 60, if you go back to what you did yesterday, is radical 3 over 2. And I think I'm going to go ahead and I'm going to leave example 5 for you to try. I guess I'm not going to talk it through, I'm just going to write out the answer and you can take a look at it. I guess I can't help myself but talk. If we're given the tan of an angle, to figure out what the angle is, we need to do tan inverse. Notice it is to the nearest degree. Now, this one's different because they want to ship us to quadrant 3. So my answer has come out in quadrant 1, which is 75. So I am just going to, and the sketch is not the best, I'm going to just send that 75 on down to quadrant 3. 75 degrees. So I know if I send this on down here, I have 75 degrees here. So really what I need to do is add 180 to that 75. And I get the tangent of 255 degrees. And I know that in these two quadrants my tangent's both positive. That's it. Take yourself on over to MathXL for school and give this a try. I would propose trying to draw some diagrams like I've just done.